Welcome back to my channel. This time we are going to discuss evaluating algebraic functions using the limit theorems. Alright, now there are actually 12 limit theorems that we will be using as we go along with our example. Now let us begin with the basic. Example: evaluate the limit of 2 as x approaches to 1. Now, we know that 2 is a constant, right? Now, the theorem behind this is the limit of a constant, wherein the limit of 2 as x approaches to 1 is just 2. Next example. Find the limit of the quantity 2x minus 3 as x approaches to 1. Now this time, we are going to apply another theorem called the limit of a linear function, wherein in order to determine the limit, all we have to do is to simply substitute our value with x with 1. That means you will then have 2 times 1 minus 3, which is equivalent to negative 1. Third example. Find the limit of x as x approaches to negative 1. Now this is an example under the theorem limit of identity function, wherein to do that, we simply again substitute our value of x with negative 1, in which the limit of x as x approaches to negative 1 is indeed equals to negative 1. Fourth example, we have determine the limit of quantity 2x times the quantity 3x squared as x approaches to 2. Now this is an example under the theorem limit of the product of two functions, wherein all you have to do is to simply again substitute all the values of x by 2, in which you will then have 2 times the quantity 3 times 2 squared, wherein it is equivalent to 48. Alright, next we'll go to example number 5. Find the limit of the quantity 4x minus 5 raised to the power of 2 as x approaches to 2. So again, all we have to do is to simply substitute our value of x by 2. So you will then have 4 times 2 minus 5 raised to the power of 2. So 4 times 2 is 8, minus 5 is 3. 3 squared is now equivalent to 9. Example number 6. We have determine the limit of x squared minus 3x plus 5 as x approaches to negative 1. Now, substitute all our values with negative 1. So you will then have negative 1 squared minus 3 times negative 1 plus 5, which will give you the answer of 9. Example number 7. Find the limit of the function 4x minus 5 all over 2x plus 1 as x approaches to 3. So we substitute all our values by all our x values by 3. So you will then have 4 times 3 minus 5 all over 2 times 3 plus 1, which is equivalent to 7 over 7 or 1. Next example number 8. Find the limit of the cube root of 2x squared plus 4x minus 5 as x approaches to negative 1. So substituting all our values, and then you will have cube root of 2 times negative 1 squared plus 4 times negative 1 minus 5, which will give you the final answer of the cube root of negative 7. Now let's go to example number 9. Find the limit of the function as x approaches to 1. Again, substitute all the values of x by 1, and you will have the square root of 1 squared minus 2 times 1 plus 3 all over 3 times 1 minus 1. Doing all of the necessary manipulations, and you will have the final answer of square root of 1, which is equivalent to 1. Alright, now let's go to example number 10. So we have the limit of 1 over x to the power of 5 as x approaches 0 from the right. Now what we have here is a one-sided limit. Now in order to evaluate this type of function, no, we will be using this theorem. So theorem 11, wherein if r is any positive integer, then the limit of 1 over x to the power of r as x approaches 0 from the right is equals to positive infinity. And if the limit approaches 0 from the left, so there are two cases that you need to consider. First is that if r is even, then it approaches to positive infinity. If r is odd, then it approaches to negative infinity. Now, to go back with our problem, so you have 1 over x to the power of 5. So it falls on the first scenario, wherein the x approaches 0 from the right. Now, we now have the answer, positive infinity. Okay? Next, let's go to example number 11. Now this time, our value of x approaches 0 from the left. So it falls on the second case. And your exponent is in odd. No, it is in odd. Therefore, it approaches to negative infinity. Now, if the exponent here is even, let us say 4, 6, 8, or any even numbers, then it will approach to positive infinity. But since it is an odd number, so it approaches to negative infinity. Next, example number 12. So here, find the limit of 1 over x to the power of 8 as x approaches 0 from the left. So this is an example, no, with an even exponent. So again, it will approach to, or the limit is positive infinity. Okay, next, let's go to example 13. Find the limit of 3 over x minus 2 as x approaches 2 from the right. Now this time, we are using another theorem for this example. So what theorem is this? Now this is what we call, theorem number 12, wherein if a is any real number, and if the limit of f of x as x approaches to a is equals to c, where c is a non-zero constant, and the limit of g of x as x approaches to a is 0, then there are 4 possible cases that we need to consider. First is that if c is greater than 0 and g of x passes through positive values of g of x, then you will have positive infinity. If still c is greater than 0 and it passes through the negative values of g of x, then your answer will be negative infinity. Now, if c is less than 0 and g of x passes through positive values of g of x, then your limit is negative infinity. And still, if c is less than 0 and g of x passes through the negative values, then your limit will be positive infinity. Now observe here, what we have here is that our numerator, which is 3, is greater than 0. So it falls in either the first or the second case, right? Now, second thing that you need to consider, our x approaches to the 2 from the right. So that means positive values of g of x. So if you try to go back again with our theorem 12, it falls under the first case. Okay? It falls under the first case, wherein your answer would then have been this one. No? So you have the limit of 3 all over x minus 2 as x approaches 2 from the right. So substitute all the value of x with 2. So we have 3 all over 0 from the right, which is positive infinity. Okay? Alright. Now, example 14. Find the limit of the square root of 2 plus x all over x as x approaches 0 from the left. Okay? Now, if we try to substitute our value of x by 0, you will have the answer of the square root of 2 all over 0 from the left, right? Now, the square root of 2 is by far greater than 0, and your denominator passes through the negative values of g of x. And that means it falls on the second case, wherein your answer would then have been negative infinity. Okay? Now, in general, for rational functions, f of x equals p of x all over q of x, where p of x and q of x are polynomial functions, and q of x is not equal to 0. If a is in the domain of f, then the limit of f of x as x approaches to a is equals to f of a. Now, expressions such as 0 over 0, infinity over infinity, 0 times infinity, or infinity minus infinity, or 0 to the power of 0, or infinity to the power of 0, or 1 to the power of infinity are called indeterminate forms. If after direct application of one or any combination of limit theorems from 1 to 10, we encounter an indeterminate form, then we evaluate the limit of the given function after some algebraic manipulations. Okay? Now, how are we going to do that? So, for example, we have example 15. So, we have find the limit of x squared minus 9 all over x minus 3 as x approaches to 3. Now, if we will try to substitute the value of x by 3, you will have the answer of 9 minus 9 over 3 minus 3, which is 0 over 0 in its indeterminate form. Now, we need to do an algebraic manipulations to simplify our function so that you may be able to determine the limit. Okay? So we now you have to be reminded that x squared minus 9 can be broken down into the factors x plus 3 and x minus 3. Wherein, you can now cancel the x minus 3 from the numerator and the x minus 3 from the denominator. So canceling these two, that will leave you with the limit of x plus 3 as x approaches to 3. Now substitute our value of x by 3. So 3 plus 3 is equals to 6. Therefore, the limit of our function as x approaches to 3 is equivalent to 6. Okay, now let's go to example number 15. Find the limit of the function the square root of x minus 2 all over x minus 4 as x approaches to 4. Now, if we directly substitute our value of x by 4, you will have the answer of the square root of 4, which is 2. 2 minus 2 is 0 all over 4 minus 4, which is equals to 0. In that case, you will have its indeterminate form. Now, what are we going to do to determine the limit? So we need to make some manipulations with our function so that we may be able to determine the limit of it, right? Now, you have to be reminded that all we have to do is to use the conjugate of your numerator. Okay? Wherein, all the conjugate, when you say conjugate, all you have to look for is the sign, the opposite sign. Alright? So since you have here the square root of x minus 2, its conjugate is the square root of x plus 2. Right? So we multiply our numerator and denominator by square root of x plus 2 all over square root of x plus 2. Now remember that we have now binomials, right? So sum and difference of squares. Diba? Sum and difference of squares. So you have square root of x minus 2 times square root of x plus 2 is now equivalent to x minus 4 all over x minus 4 times quantity square root of x plus 2. Now this time, we can now cancel x minus 4 from the numerator and x minus 4 from the denominator. In that case, you will then have the limit of the function 1 over square root of x plus 2 as x approaches to 4. Now this time, we can now substitute the value of our x, which is equivalent to 4. So substituting all the value, we then have 1 over the square root of 4 plus 2, wherein square root of 4 is 2 plus 2, which is equivalent to 1/4. Alright, so that's it. I hope you learn now how to evaluate the limit of algebraic functions using the limit theorem. So that will be all for now. I'll see you on my next discussion. Bye bye.